Hello everyone, this is Travis, and I'm here to tell you about the wonderful force that is friction. Friction, the thing that keeps us on the ground and not slipping and sliding all over the place. Now, you might be wondering, why is it that this piece of wood is not going down this ramp? After all, conventional wisdom would say this is on an incline, therefore it should be just going down this ramp like it should. Well, that's because of static friction. Now, friction is the force that happens between two objects. This object right now, there are a bunch of little ridges and such that are interacting between this block of wood and this block of wood, and they're both interacting with each other like this, keeping them from actually going down. If you roll a ball on the carpet, or if you try to roll it through grass or something along those lines, it's the same principle, and it's what brings it to a stop. In this case, it doesn't have enough force to keep it moving or to even start it moving. This is called static friction. Now, if I were to apply some force like so, we can see that it's actually able to begin moving, and that static friction force is the force that's needed to start the initial motion. Now, let's say if I were to keep it going like that, now we've transitioned into kinetic friction, because now it's moving on its own, by its own force, and on top of that, most importantly, it's having continued interaction with that surface until, again, it ends up reaching that same point. And the reason that happens is all these little ridges, we can see how that interacts. So if I'm, bringing this wood up, if I were to keep pushing on this, I'd actually knock over this simple ramp here, because there are ridges here that are preventing this, and it's the same concept that occurs. If we look over here, we can see again, tons of little ridges and texture. So if we were to smooth this out or do something different, then that might help. One way that we can smooth it out is by smoothing out one of the surfaces, in this case, the wheels on this car. Now, just to demonstrate quickly here, we're going to have some rolling friction. Now, what rolling friction does, it allows the car to move on top of this surface. And because of how smooth these are, it's far easier and gets a lot more out of the momentum. In fact, it could even go off this table. So, if we were to, we can also see that there are other areas where we can see other types of friction. There's friction between the axle and the car itself, so that all of this is happening. So there's still friction going on, anywhere on this car, even though the wheels are having a much easier time. Now, if we were to say apply some lubrication, I've got some soap here on a paper towel that we'll use just for that purpose, even though it's a bit more bubbly right now. You can go ahead and give it a shot. You can see it rolls down a bit faster than it normally does. So anyways, what that lubrication does is it would, in theory, it would be lubricating this area right here and the wheels themselves between the surface to put some, liquid or some kind of thin fluid that's a lot smoother, of course, than this very bumpy surface. Now that we've looked at how friction works and what friction is, we can actually get into start calculating it. So, by measuring the weight of this car, we know that it is exactly 34 grams. Now, if we convert that to kilograms, that's a simple, clean 0.034 kilograms. Inch-wise, we previously measured the board, which it was 23 inches, which is about 0.6 meters. Now, if we look at the time, we again measured this beforehand, and it was again about 1 second. So now we have our mass, which is 0.034, times our acceleration, which is just 0.6 meters per second squared. So, boom. Now, if we come back over here, plug it into our equation, the idea of net force, which is basically that for all these forces like friction that's acting against it, this is all of the forces taken into consideration, just the force of the car moving down, the force that I've applied to it to get it to move down, and the forces resisting that. So now if we go ahead and we can multiply the 0.6 times times the 0.034, obviously, because it's multiplication, it doesn't really matter. And if we just step over here to our calculator, we can just look at what 0.0 to 0.6 is, times 0.034, and it's about 0.0204 for our net force. Now we've gone ahead and calculated Newton's second law of motion. Now we can look at the idea of weight during acceleration. So when you're accelerating, the idea is that you're, depending on the direction, you're going to either gain or lose weight. Think of it like an elevator. If you're going up, you're going to have more force pushing down on you, being the force of gravity, versus if you're going down, you're actually going to feel lighter, while you might get a slightly lighter feeling going down. So, looking at this, we've got our mass, we've got our acceleration, now we just need to go ahead and plug in numbers. So remember, for our mass in kilograms, we have 0.034, and for our acceleration, we have 0.6 meters per second squared. If we go ahead and multiply all this together, we get roughly 0.35 for our scale force. Moving on to the idea of maximum friction force, we've got our what is our coefficient of friction for kinetic. So if we look at that, what we can see is basically this is our plastic on wood. So these are our plastic cars on the car, and this is of course, our wood ramp. So that's 0.4 times our net force, which is 0.204, and that gives us a total of 0.0816 for our maximum friction force. All right. Anyways, thanks for watching this video, and I hope you learned something on this crash course of friction.